Pilot is planning a flight from position X to position Z via the shortest distance between X and Z. Given the following information, calculate the final true track between the two positions. Position X located on 37 north, 10 degrees east. Position Z in the northern hemisphere, but exact coordinates are not provided. Convergency, however, is between X and Z is 20 degrees and initial true track direction is 122. So for these questions, I really like to visualize it. So I will just draw here. So this one, let's say this is X, yes, and this one is Z. And the question is asking how many degrees, what will be the true track when we arrive to position Z, yeah? So it's asking for us the shortest distance between X and Z, and we know the shortest distance is with the great circle track. So the true track will be always changing when you're moving along between X and position Z, yeah? And this difference will be 20 degrees. So your true track will change by 20 degrees maximum. So let's get back to the question. We know that we departed with 122 degrees initially, so it will be something like this. So it will be 122 degrees, and we will be flying like this, and we will arrive like this, yeah? When we arrive here, this distance is asking. So we know that when we are flying towards the east, first the degree will be northbound, then it will be southbound. So it will be curved. If I give an example, this is X, this is Z. If they're on the same, like 37 north, the flights will look like this. First it will increase, then decrease. If you're on the northern hemisphere, because it has to be concave. So from this point of view, we know that we depart with 122, then we will have an increased degree of plus 20, because we know our convergency will be 20 degrees. So when we arrive to position Z, it will be at the maximum, like from departure to arrival. So we need to add actually 20 degrees more to our true track, and 122 plus 20, that will give us the only answer, D, 142. So it's basically about the convergency, and it already gives us the convergency between X and Z. The only crucial part on this question is you need to know if you're on the northern hemisphere, southern hemisphere, and if you're flying towards east or west. How did I understand that we are flying to east? Is because our initial true track is 122. That's it for this question, and thank you for watching.